Morning, ma'am.
Good
Good morning, ma'am.
Okay.
Good morning, ma'am.
Our mobile computing class.
Good morning, ma'am.
As I already told you that this class will be starting with any doubts regarding the antennas topic. Right. So if anybody having any doubts regarding the antenna topic, you can raise. Anybody having any doubts?
Door lock చేసేస్తా.
Please mute yourself while class is going on. If and only if you are having any doubts, then only unmute yourself. If there is any disturbance at your background, please mute yourself. Otherwise, you can unmute. Or if you are having any doubt, you can unmute. Yes. Regarding the previous classes, if anybody are having any doubts, please be get clarified. Otherwise, we'll have a short review session. We'll be continuing with the next. Anybody having any doubts regarding the transmission media or any antenna topics?
No, ma'am.
Shall we go with the next one?
Pen, ma'am.
Hello. Shall we go with the next topic?
Yes, ma'am.
Yes, ma'am.
Okay. See, please be remain silent while the class is going on. If anybody wants to raise your question or any doubt, or if there is any connectivity issue, please be put a message in the chat box. I will respond to you. Okay. But don't be over cumbersome with your voices at the same time. Right. I'm not going to mute you all, but don't be do any mischievous things while the class is going on. Hearing something in your classes, something is going on in your classes, but don't do that. And be remind to your juniors while online classes are going on. Right. Already you know that some other staff other than your teaching staff, separate staff is there to monitor your activities and also your presence regarding your attendance. If you do any mischievous things, obviously you will be in your risk losing your attendance, right? So now you'll move into your class now. Coming to your last class, we are being discussing with the antennas. One second. So discussing in the fundamentals of mobile communication, we discussed about what is the definition of the mobile communication, transmission of the to and fro transmission of the data streams from the source to the destination, and next the corresponding things, the mobile communication. This mobile communication concerns with the same to and fro communication of both the parties who are being communicating, that is both the source and the destination, whereas there may be many number of parties, not only between the two parties, and among which number of parties they are being communicating in the mobile communication. We know that one of the device could be the handheld devices, right? So other than the handheld devices, other remaining devices can be wired or non-wired devices. So communication will be between the two parties of the two communicating devices, and those devices may be mobilizing locally or globally in mobile communication. And for knowing about the mobile communication in detail, we need to go through some fundamentals of it. In that list of fundamentals, we have been discussing with the transmission media, and the transmission media is nothing but a media or means through which the data streams are going to pass through in between the source and the destination who are being communicating. And that particular transmission media are of two categories in our mobile communication: guided transmission media and the unguided transmission media. Guided transmission media includes some hardware devices like optical fibers or the metal fiber wires, which are going to carrying the signals through them to transmit or to convey the information from source to the destination. And coming to the unguided transmission media, we are having no specific guidance for the signal to carry from source to the destination. They will be radiating in the air. Right, guided transmission will have certain advantages and the disadvantages, as there will be a one-to-one connectivity, will have less interference from the external resources of the particular transmission area, so that the signal will be intact, transmitted from the source to the destination. And whereas the disadvantage of the guided transmission will be, there will not be any mobility of the source and the destination, even though we are having the multiple connections among the multiple source and the destinations. Multiple connectivity is possible using the multiplexing or coding. And because of that, even though we are going to have the multiple connectivity possibility, we'll be having the lower standard of the quality of the signal among that particular tedious and the difficult connectivity of the connections. And coming to the transmission media, that is the unguided transmission media, how the signal is going to be transmitted in the air without help of or without any guidance of any wire or any specific fiber or whatever it is. Here, the signals are going to be converted from the electrical property to the electromagnetic property. That is, the electrical signals are going to be converted into the electromagnetic signals, whereas these signals will be transmitted or flowed into the air using the antennas. Antennas are the components which are going to be radiating our electromagnetic signals into the air. And those range of the antennas are going to be ranging from a single piece of wire to a parabolic dish, right? And among the antennas, we already been discussed various categories. That is lambda by 4 dipole antenna and lambda by 2 dipole antenna and the directed antenna. Right, coming to this lambda by 4 dipole antenna, here the antenna is consisting of the two poles that the name implies the dipole. Di is nothing but the two, that is, it is having the two poles in the antenna structure. And why it is being preceded with the lambda by 4 means that its wavelength, the signal that is being propagated by the antenna, which is having some wavelength and frequency with it, its wavelength will be get divided by 4 times. The signal is going to be transmitted with its original wavelength get divided by 4 times. But because of this lambda by 4 dipole antenna, the transmission of the signal will not be properly in all the directions. Even though the signal, the particular antenna is going to be situated here at a specific height, then only the transmission is possible on the either side of its antenna, right? Sorry. Next one is lambda by 2 dipole antenna. Here the antenna is going to be completely situated right from the ground itself, and here the wavelength of the antenna is signal that is being transmitted. Hello? Anybody is having any problem or any doubt? Okay. So this dipole antenna has been situated right from the ground, and its signal is going to be divided by its wavelength by 2. That is, half of the wavelength is going to be get transmitted by this dipole antenna, right? And its radiation pattern will be like this. Whatever right from the ground it is being situated, that is the antenna is being. So right from the ground itself, the signals are being transmitted on the either side of the signal. I mean, that particular antenna. So there will not be no specific discoverage from this particular radiation pattern from the lambda by 2 dipole antenna. And coming to the another one, that is the directed transmission antenna. So the parabolic dishes, what we have been discussed in the previous class, which has been used for the satellite transmission earth stations and also the cable transmission parabolic dishes. So what we have been seeing in on the terraces of the highest building or highest stored buildings, that particular antennas will be directed transmission antennas. And this particular directed transmission antennas are going to be transmitting their range of signals in this pattern. That is depending upon the direction that it is being set for. Depending upon the direction that it is being set for, it is going to be transmitting the signal in that particular direction itself. But in that direction, it is going to be covering the maximum distance depending upon the strength of the antenna that we are being constituted. Depending upon the strength of the antenna that we have been constituted, it is going to be spreading its signal strength covering to the maximum area depending upon the strength of the antenna. The area that is going to be covering will be denoted here. It has been denoted. Depending upon the strength and the design of this particular directed transmission antenna types, the transmission signal or transmission pattern can also be varied like this. That is, we may have the circular radiation pattern also. That is not only in a specific direction, not only in a specific direction, depending upon the size and the type of the design of the directed transmission antenna, we will be having the direction pattern or the radiation pattern will be this way. That is, the antenna is going to be covering the 360 degrees of its signal strength around it or surrounded by it. It is going to be covering the 360 degrees of the area surrounded by it by depending upon the design or the size of the antenna that you are going to choose. So that is the advantage of this directed transmitted antennas, right? So we've been discussing with three types of antennas: lambda by 4 dipole antennas, lambda by 2 dipole antennas, and the directed transmission antennas. This directed transmission antennas are going to be meant for a specific direction. In this, the particular direction, we are going to covering a specific area depending upon the strength of the antennas, right? So among the fundamentals that we want to discuss in mobile communication, we discussed about the transmission media and we discussed about the frequencies that we are going to cover, and we are also discussed about the antennas. So what we are being reminded with the specific fundamentals of the mobile communication is nothing but propagation of the signals and the modulation. So before getting into the modulation techniques, okay, so before getting into the modulation techniques, so we'll see how the signal will be get propagated. What could be the problems that we face in propagation of the signals, and why we have to go for the modulation, why we have to go for the modulation of the signals, and what could be the problems that you are going to face with the propagation of the signals. Then we'll move with the networks and the protocols then, right? So what is the propagation of the signal? Propagation of the signal is nothing but what is the signal of the strength, signal strength, what is its frequency, what is the wavelength of that signal, and how it has been moving over the ground and over the air. That is on the earth and over the air, over the earth. How the signal is being moving from source to the destination. How the signal is being moving from source to the destination. That is nothing but the propagation of the signal. See here, if you are having the guided transmission, we will be having the directed connected path between the source and the destination. A wire or a connection will be there in between the source and the destination. We won't bother about the corresponding strength of the signal or the losing of the strength of the signal. Or if any is there, we will be inserting some amplifiers or the boosters in between in order to increase the signal strength for reaching the as it is signal which is being sent from the source at the destination. So at the destination, whatever may be the signal that has been sent by the source, it is to be regained. That particular regaining of the signal will be done if and only if there will be boosters and the amplifiers in between, right? So, but again with the wireless propagation, that is the unguided media. With the unguided media, we couldn't guarantee or we couldn't give the reliability of the signal to be reaching the destination with as it is strength that is being sent by the source. So what happens? What could be the complications or the problems that faced by a signal that is being sent by the antennas through this wireless transmission? So through this wireless transmission, the electromagnetic signals that are being radiated by the antenna are going to face many problems while they are being traveling in the air. While they are traveling in the air, the signals are going to facing many number of problems. So what sort of problems they are going to face? So the complications include height and size of the antennas first. Height and size of the antennas first. Even though the signal is being transmitted from a mobile to mobile, say, the mobile antenna will be very smaller in size. The mobile antenna will be very smaller in size, even though we couldn't see. And that particular antenna is going to be transmitting the signal into the air. The same signal has to be received by the corresponding network antenna, and that antenna has to be retransmit the signal to the destination, right? And the destination mobile has to receive the signal on its antenna. So for that one, its own base station antenna has to receive the signal. I think I am clear what I am saying. In terms of mobiles, you have been discussing, isn't it? Am I clear for you?
Yes, madam.
Right.
Yes, ma'am.
See, yeah, we are discussing about the mobiles. So mobiles are being communicating with each other, right? And mobiles are having the internal antennas or internal receiving parts with them. And to receive the signal for us, we do need some antennas which are being imparted by the network providers. So we, without that particular network provider antennas, we couldn't receive the signals into our mobiles, right? So for that one, we need the antennas in our mobile and also the destination mobiles also. So while doing this, the antenna size refers with the network provider antenna will be higher in size, whereas the mobile antenna will be lesser in size. The mobile antenna will be very minute in size, whereas the network provider antenna will be higher in size. So that is the first main difference that you are going to facing, right? In wireless propagation, antenna height and size at mobile terminals will be generally quite small in size. So what happens, ma'am, with this particular lesser size of antennas? So what could be happening this because of the lesser size antennas is nothing but we will see. Propagation properties. Whenever our antenna is going to be differing its in size in transmitting the signal, whenever our antenna is having the differing in size while in the receiving station and also transmitting antennas, a mobile will be there. Our mobile is there, right? And a receiving antenna will be there at our locality. And again, at the destination, a receiving antenna will be there. And the destination will be there. Destination mobile will be there, right? See, the corresponding height differences are there in propagating the signal. The signal has to be transmitted in this direction, isn't it or not? The signal has to be transmitted in this direction. We are sending the destination mobile is here. The destination mobile is here. Our mobile is here, which is very lesser in size, whereas network provider antenna is at higher stage and the receiver network provider antenna is also at higher stage, so that the corresponding source, that is we are sending a signal to the antenna first. The antenna has to be transmit the signal to the receiver side antenna, and antenna has to be retransmit the signal which is being received by to the receiver mobiles. So these are the height differences that are being faced by this corresponding signal in the air. I think you people got me, right? So this is the influence that a wireless propagated signal will face. A particular lower height to the higher height, it has to travel first, and it is going to be balancing in the corresponding receiving and sender network provider antennas, and again it has to travel down to the earth. Again it has to travel down to the earth. And at the same time, the source, sender, and also the destination, that is receiver, may not remain static. The source and the receiver may not remain static. At that moment, we are going to be facing the problems in receiving the standard signal strength. We are going to be getting fluctuated and the signal strength will be getting dropped while it is going to be propagating at different distances and also traveling to the various places, and it's going to be, that is the moving, the source and also the mobile or the receiver is going to be moving. Either any one is going to be moving or both are going to be moving. It has to change its directions, and also it is going to be changing its height of propagation. Height of the propagation has to be changed. Directions are also to be changed. For that one, how we have to overcome that particular problem in this wireless propagation? How we are going to overcome our problem in this wireless propagation? So for that one, we are choosing a best propagation procedure that is called as line of sight propagation. Line of sight propagation. That will be called as LOS also. LOS, right? Line of sight propagation. So what is this line of sight propagation, which is going to benefiting our wireless propagation signals, which is going to avoiding this problems. So it is going to be propagating the signal in the air without without a refraction. So without refraction, diffraction, and scattering. Without refraction, diffraction, and scattering. So that's why you are going to choosing this particular line of sight propagation for our signals to reach the destination without any deviation or without any down in the signal strength. So what are this refraction and diffraction and scattering of the signals? How this refraction, diffraction, and scattering will be happen for our wireless propagating signals or electromagnetic signals in the air. We will see, right? See, and one more thing is, as we are going to be having the larger distances, as we are going to moving the signal to the larger distances, and direction of the signal is going to be changing, as we already discussed that the signal is being propagated from minimum number of height to the maximum number of height, and it is going to be coming from maximum number of height to the minimum number of height, right? And it is going to be propagating, or it is going to be changing its direction depending upon the variation of or the situation or the location of the sender and also the receiver. Where while they are going to be moving, the signal is going to be changing its direction, and it is also going to be changing its height of traveling also, right? At that moment, the signal radiated will be distributed over different surfaces. The signal strength will be distributed over different surfaces so that it is going to be reducing its strength. So here you are saying decreases as the square of the distance from the transmitter in free space. Whenever a signal is going to be traveling through the free space, according to the, as the distance is going to be increasing, its strength is going to be decreasing by square of the distance. If the distance is being increasing in square, obviously the signal strength is going to be decreasing, and at the same time the energy of the signal is going to be distributed onto the surfaces where it is going to be changing. As our mobiles are going to be changing its directions, where we're talking while moving, we are being receiving the signal while moving, and the sender is also being while moving. As we are going to move, our signal is going to be posing on us, posing on the network terminals. Then it is going to be changing its directions. It is going to be changing its signal strength. It is losing its strength over different areas while you are moving through. that particular signal strength reduction or downing or getting down of the signal strength over different areas as you are going to move, over different heights you are going to move, then that particular signal strength reduction is called as attenuation. Is called as attenuation. Signal attenuation is nothing but a reduction of the signal strength while it is propagating in the free space over different surface areas and different heights. Okay, and also same time it is going to be receiving the obstacles like trees, larger buildings or lakes or mountains and whatever it is. While moving over all these surfaces, it is going to be reducing its wavelength. Whenever it is going to reduce its wavelength, it can't convey the same signal strength from the source to the destination. Right? Spherical radiation pattern and light of signal strength and also signal strength attenuation. So, and at the same time, see, signal propagation of the signal length decreasing. How it is going to be decreasing is nothing but, for example, here we are being given with FM band signal transmitter. If we are having the FM band signal transmitter at 90 megahertz, at 90 megahertz frequency, our transmitter is having 90 megahertz frequency, then its wavelength will be 3.3 meters. Its wavelength will be 3.3 meters. See here, the signal frequency is 90 megahertz and the wavelength is 3.3 meters. Then the signal is going to facing the attenuation. Attenuation is nothing but less getting down in its signal strength at objects of size 10 meters and above. At objects of size 10 meters and above. Whenever it is facing the object of 10 meters and above size, obviously it is going to be getting bombarded and it is going to be get reflected or refracted and its signal is going to be getting decreased. Right. And for example, say again a GSM signal or a transmitter at a frequency of 900 megahertz, at a frequency of 900 megahertz, and its wavelength is greater than that particular FM band, which is equivalent to our 33, which is equivalent to our 33 centimeters signal, and it is going to be facing, even though it is going to be having only the 33 centimeters, whereas FM band signal is having the 3.3 meters wavelength. The GSM signal, even though it is having the frequency of higher, and already we discussed about that, if it is of higher frequency, we will be having the lesser wavelength, so that it is having only the 33 centimeters wavelength. If it is having the 33 centimeters wavelength, obviously it is going to be facing the attenuation with the objects less than 1 meter itself. It is going to be facing the attenuation, that is, it is going to down in its strength in less than 1 meter itself. Obviously, if any object, it is facing any object less than 1 meter in height, obviously its signal strength will be getting reduced. Right? And clear now? As the signals are being propagating in the space, as the signals are being propagating in the space without any wired media, without any guide through convey the signal, for conveying the signal, they are going to facing the some problems. That particular problem is nothing but signal attenuation. Attenuation is nothing but decreasing its signal strength. Why it will be decreasing the decreasing its signal strength is nothing but as the users are being moving, that is both the source and the destination, and height of transmitting and receiving antennas, obviously they are going to be losing their energies, that is the signal is going to be losing its energy at different places, that is on the earth surfaces or in the air and on the height of the antennas. As it is moving its directions, the signal is moving its directions and also moving, varying in its height of transmission, obviously the signal is going to be reducing its strength or energy in it. That particular energy reduction will be called as signal attenuation. Here we have been given an example called as 90 megahertz FM band signal transmitter having the wavelength of 3.3 meters is going to face the attenuation while transmitting in the air whenever it faces an object of above 10 meters, as it is having the wavelength of 3.3 meters, it is going to face the attenuation at above 10 meters of height of objects. Whereas GSM is having the more frequency when compared to the FM band signal transmitter, And this GSM, obviously as it is having the higher frequency, it will be having the lesser bandwidth. So that particular signal is going to obviously faces attenuation only below the, only above the 1 meter itself, not the 10 meters as in the case of FM band signal transmitter. Here below the, above the 1 meter objects itself, it is going to face in the attenuation, right? And as we are choosing the line of sight propagation in order to avoid and overcome this signal attenuation, this particular signal attenuation can be avoided and overcome by using the line of sight propagation, as we already discussed. So what this line of sight propagation is special about it? It is going to be propagating the signal without the reflection, diffraction, and also the scattering, without refraction, reflection, and scattering of the signal. So what is this reflection of the signal, refraction of the signal, and also the scattering of the signal? But because of these three things itself, we are going to facing the signal attenuation itself. So avoiding these three, we are going to have the line of sight propagation. Avoiding these three, we are going to have the line of sight propagation, right? In my system, the time is showing that it is going to close in 1 minute, right? I'll restart it. Don't bother and don't worry if the meeting closes in, right? I will restart if at all it is closes in 1 minute, right? So what is scattering here? See, here the transmitter is there for us. Sorry, transmitter is here and receiver is here, and in between we are having certain object. In between we are having an object. The transmitter is the GSM transmitter with 900 megahertz, right? And it has been transmitting the signal, and it is being faced with an object with above more than 33 centimeters wavelength. As our transmitter is having the 33 centimeter wavelength, obviously whenever we are facing an object more than 1 meter height, the signal is going to be transmitted in multiple directions. The signal